All right, I think we can probably go ahead and get started. I know some people are still entering. So for those of you who are joining, welcome, and welcome to the final session of the day, Interiors Matter, Material Impacts, Innovation, and MEP. So far in this embodied carbon track, we've talked about high impact structural materials like concrete, steel, and mass timber, as well as naturally carbon sequestering materials. And in this session, we're going to dive into interior materials, tenant improvement cycles, and MEP systems. So for those of you looking for AIA continuing education credit, the learning objectives of units are shown here. And we'll follow up after this event with a survey on getting a survey to submit your AIA member number for credit. And if we don't get to any of the questions, I will ask Louise and Louisa to answer those, and we'll post that on the CarbonPositive website. We'll also be posting all of the recordings on the CarbonPositive website where you found the link to this session as well in the coming week. So with that, I'm looking forward to introducing our two speakers. I'll keep their introductions brief, but their full bios are on the CarbonPositive website. So up first, we have Louisa Bowles, partner and head of sustainability at Hawkins Brown. Louisa leads the practice's dedicated team of sustainability specialists and has structured the practice's whole life carbon strategy to ensure all projects are measuring and monitoring the balance between embodied carbon and operational energy. She was instrumental in development of the, I believe, Herbert tool, which is free and open source, Hawkins Brown's Revit-based carbon measuring tool. Louisa is joined by Louise, Global Lead of Lifecycle Research at Integral Group. Louise supports colleagues involved in LCA work across North America, Australia, and Europe to advise architects and clients on design strategies to improve their environmental impact. With a degree in both architecture and in engineering, she has a strong understanding and experience in regenerative design, holistic thinking, and integrated design. And with that, I will pass it over to Louisa.
Thank you for that detailed introduction. I will share my screen and we'll get started, and then I will hand over to Louise. So, thank you for the detailed introduction, Lindsay. Means I don't need to introduce myself. What I was going to talk about today was embodied carbon and whole life carbon, the impact of interior packages, strategies for reducing the impact, and then a couple of case studies. So for those of you who don't know, Hawkins Brown are a large architectural practice with 280 staff. Our head office is in London. We have offices in Manchester, Edinburgh, and LA as well. And we work across a range of different sectors, so it means our approach to sustainable design has to be quite flexible, respond to a range of different clients, contexts, and scales. And so for this reason, we've been researching embodied carbon heavily, how to measure and visualize it for a few years, because this metric directly represents the choices that we feel we need to make as architects, and where our choices can have huge effect over reducing carbon emissions. So we found huge benefit in analysing both embodied carbon and monitoring operational energy to understand the whole life carbon implications of our buildings in order to make the right decisions really early on. We're using the metric as a new design driver, recognising the balancing act required to optimise it. We've had some really good traction in the office talking about the RBA 2030 climate challenge targets and then breaking them down using industry research and our own in-house data into elemental targets to show what the big wins are. And then also looking at some target metrics. As you can see, interior finishes are not the biggest contributor, but they are still large on day one. And then we also need to look at replacement patterns, which have a key impact. So we've been emphasizing how important it is to make the right decisions early on in a project. And if you haven't tested comparative options and locked in the low carbon ones, by the end of RBA stage 2, in our experience, it's really hard to catch up. It's pretty rare that interiors are considered in that much detail at this stage, but the whole life carbon approach encourages designers to do this more, perhaps than they're used to. And part of this exercise is also communicating with clients and project managers to make sure that the program is right, the consultant scopes include everything they need to, things are costed, and the topics included in early stage design meetings. So we've been educating the office about the embodied carbon within raw materials, understanding those with the highest loads. Metals come up the highest, so we try and reduce the use of those. And as you can see, bio-based materials generally perform much better. So the basis of our approach is to try and veer towards those. In terms of reducing the impact of interior packages, there's a strategy that we're trying to strategically apply to make early stage design decisions. So eliminating unnecessary elements, so not finishing something that doesn't need to be, long life, loose fit, cleaning and maintenance, designing for lease arrangements so that fit out items are not installed day one when actually the tenant's going to change them and dispose of them. Minimizing replacement cycles, so working out with the landlord and tenant what can last longer, and then ensuring replacement cycles are sustainable and circular, and then designing for longevity and not for current trends. So the building here was the student hub at Coventry University. It was completed a few years ago now, but instinctively to meet the budget, and we find this a lot, cost correlates quite a lot with carbon. So reducing carbon often can then reduce cost as well. To meet the budget here, these methods that I've just explained were employed, and the building that we designed for Coventry was a really regular grid, flexible, long life solution, with the furniture elements providing the spatial division, which can be more flexible long term. Secondly, on strategy, looking at building material sizes and modular options, self-finishing materials, thinking about the color strategy so that you design the long-lasting elements of the building are neutral. And then if there's color desired, they're put into the elements that are a bit more flexibly arranged. Of course, the previous example had an in situ concrete frame, but we are increasingly getting some interest in timber structure where the regulatory and the insurance market will allow it. And this does prove an excellent way to decrease embodied carbon and gives also the opportunity of expressing the material. Wanted to say something on replacement cycles. Interior packages are those that are most affected by these because they tend to last less longer. They get more use and there's more footfall on them, and they don't last as long, especially with plant and lighting, for example, which is one of the first items on this graph. I have to credit one of my London Energy Transformation Initiative colleagues for this graph, but I think it shows some of the industry standard life cycles of specific products and the carbon emitted at each replacement stage. So the carbon at A is basically your day one carbon. And as you can see, B4, which is the replacement, can sometimes be as much carbon over the 60-year lifespan of an asset as the original day one carbon. So keeping an eye on replacement cycles in interiors is really important. So we've also been looking at the implication of replacement cycles in a quantitative manner. So if you consider an office building, for example, 10,000 square meters GIA, looking at benchmarking the carbon against the RBA targets, the carbon will be 5,000 tons of CO2 in total when first built. The interior packages will be a percentage of that. And then if a typical commercial refit program is 15 years, over a 60-year lifespan, this could be 3 cycles of replacement. So about 66% of the original carbon emitted. So another thing we've been looking at is alternative options to standard partition build-ups, reviewing the impact of replacing metal elements with timber where it's possible, using alternatives to plasterboard, and also looking at the opportunities for carbon storage. So if you build your partitions out of CLT, there is opportunity for carbon storage. We have been looking at also the specification and materials in products through comparing EPDs. I think some notes on EPDs, environmental product declarations, ensure they're relevant to the system and the location proposed. So sometimes suppliers do produce generic ones, so ensure they're right for the product that you're looking at. as I've said before, designed for longevity. I think, again, in relation to EPDs, variations can occur depending on the material thickness and the panel size. So again, make sure the EPD matches what you're intending to use if you want to do comparative studies. General rule of thumb, eliminate harmful chemicals and formaldehydes and VOCs. And for end of life, avoid composite materials and products. You can see the variation across the same product even in this graph. So for example, carpets vary hugely due to their weight. Denser carpets have more embodied carbon. The percentage of recycled content, which affects the embodied carbon reported in the life cycle stages. So higher recycled content means less embodied carbon reported. And also the backing system of carpets really important. So bitumen versus wood-based resin, wood resin-based, for example. So there's a lot of analysis to do there, looking at particularly finishes, floor finishes with the high footfall. We've been looking at innovative bio-based products, so bio-based alternatives to some of the standard products that we'd normally specify. Some ideas that we've been looking at on projects recently are shown here. So furniture made from paper bricks, hemp husk, acoustic panels, newspaper wood, looking at acoustic wood wall panel, precast rammed earth panels, and exposed clay blocks. Again, self-finishing materials that are robust and will last a long time. So some case studies. I'll conclude with a couple of zero carbon, this zero carbon case study for a hotel. I'm sorry about the fuzzy graphic. But it began as a collaborative research project with Arup for a developer named Castleforge, but we hope it can be one day delivered. Basically, we designed a whole carbon model around stage 1 design and based it all around bio-based materials. We managed to get the embodied carbon and the operational carbon so low that we could then offset the carbon loads to zero through that study. So it gives something that's deliverable and tangible for the developer. And then secondly, this wasn't zero carbon, but it represents the amounts of savings that you can make through utilizing timber and self-finishing materials rather than perhaps a standard metal frame. So 132 tons of carbon saved there. And the calculations that I've just gone through on those case studies are carried out in-house on our in-house tool HBERT that Lindsay mentioned in the introduction. It has various comparisons set up on it, but this is the example of one of the outputs that tells the whole carbon life story of one project. You've got all the whole life carbon data on the left, and then the materials breakdown on the right, showing where the highest loads are. And then the materials are color-coded. So some general rules of thumb. Start the process early. Understand the occupant, the facilities management arrangements, and the potential replacement cycles. Embed alternative specifications into the cost plan, and again, really early on. Know which material groups have the highest embodied carbon in raw form. Use the data and visualize it to drive discussion and decision making. Keep monitoring. Make sure that your specifications are being pulled through, and interrogate supplier information. And if you do want to have a go with HBERT, the embodied carbon version of HBERT is available on our website if you want to give it a go. Thank you very much. I'll hand over to Louise.
I think, Louisa, you need to stop sharing so I can share.
Oh, okay. Yep, I can do that.
Yeah.
Thank you.
Can you see my screen all right? Lindsay or Louisa?
Yes, looks great.
Yeah.
Do you want to go full screen?
It's full screen. It should be full screen.
Yep, there you go. Okay.
Hi, everyone. Thank you, Lindsay, for inviting us to speak today. And thank you, Louisa, for this great presentation. We're going to switch to another topic still related to embodied carbon, but more in the engineering world. I hope you'll find it interesting. First, we're going to start with some benchmarks that we did, tenant improvement projects, and then one retrofit. And then I'm going to be talking about different subjects, and before, key takeaways, and before Q&A session. For those who don't know us, because in Europe we're known as Elementa Consulting, and we have an office in London and Oxford, and I'm actually based in France, speaking from Paris today. But we're part of a wider group which have offices a bit all around the world, all focused in a deep green engineering. So before getting into some real numbers on how much embodied carbon is associated with MEP design, which is quite a big question for us, as building services engineers. We've long focused on operational mitigation, but now we're aware we need to look at, at the full picture to really have an effect on climate change. So before going into the numbers, I just want to approach this a bit intuitively on like how much potentially a problem and an impact it could be. And sorry, I apologize that the presentation is going to be quite data heavy, but I hope it's all right. So the first intuition is that when you need to think that we put a lot of MEP equipment within our buildings. We don't necessarily see it because it's on our risers, it's between the walls and everything, but the quantities themselves are quite massive. Second of all, most of these equipments are made of metals and plastics, and has this graph showed from the IC database that Louisa showed as well. It tends to be really the heavy carbon intensive materials, which gives like the idea that it's not going to be a small figure at the end. And the last thought on this is that MEP really have high replacement rates. So typically, as equipment itself, 5 to 35 years. But when you get into, lease that change, in tenant improvements or even in retrofit, actually the replacement rates are going to be much higher. And I'll go back to this. So I'm going to be presenting you some benchmarks. So different studies exist today on how much MEP design represent in terms of embodied carbon. So I've listed a few different studies, and Louisa gave some numbers, but we still wanted to do our own studies because we felt they were not completely robust in a way that they didn't, the scope wasn't at its maximum, we found. So we decided to work on detailed beam models where everything had been modeled, and working on extracting the data to create really accurate build of quantities that then we linked to a kind of a in-house Excel database where data is extracted from a bit everywhere, and a lot from one click because it has access to a lot of different databases. So from that process, we're able to do different studies. This one was a study we did almost 2 years ago, and you can find all the details and the results in the following article, and I'm more than happy to share the link within the conversation, where we had found that for over 30 years, it could be as high as 300 kilograms CO2 equivalent per meter square, but it was largely due also to really high impact from refrigerant due to high leakage, but I'll get back to this. But for this, this study was important for us because we needed to understand how much it was a problem in itself, but also compared to the rest of the building. And with within this study, we're able to also assess the embodied carbon impact of the building part. And this study showed us that you know, in retrofit, MEP was really a large part, and we are convinced that you know, retrofitting should be really, and refurbishment should be really our priority, you know, instead of building new. But more recently, we just did another series of case studies on office tenant improvement. So I guess in the UK, you would call it Cat B operations. And we're going to do a publication as well on this. And we decided to look at different regions to identify if we could, you know, identify potential trends and hotspots, if we could, if the learnings we would do for one case study would, you know, would be the same in other regions. So these are the results we found for these 3 different case studies, so UK, Canada, and the US. So you can see that the results is quite spread out. It's completely normal because also the scope of the work changed per project, and also what you consider as tenant improvement changed by country. For instance, in the UK project, any refrigerant-based system was actually included in Cat A, so it was not part of the scope. And so we calculated over 50 years this time, because an architecture study had been done and was using 50 years, so we wanted to compare with the rest of the building in terms of architectural impact. But we considered that we had a 25 lease period, which is quite long. Usually it's more about 5 to 10, but we know there's kind of a push for 25, and just we didn't want to have astronomical numbers right away, so that's what we chose as. And I'm just going to be detailing a bit these studies to explain a bit why the variance is so high. First, I want to talk about service life and the in-use. So in the way we modeled everything, we're really able to break it out per modules. And you can see that in this one, in this Canadian project, B4 to B5 is actually even higher than the production phase. And when we compare the results to the result from the, you know, about the architecture part, we're about, you know, 71 to 90% of the total carbon impact, not including furniture, I reassure you, but still that was a big finding for us. And really it's like, so it's another way just to put it, but that the use phase is really important, especially in the case of MEP. And maybe we should, you know, review all this kind of this trend of when there's another lease coming up, that idea that we need a shiny ceiling, shiny floor, and you rip everything off and then you start again, maybe it's not the best idea, and that we have actually a huge impact when we do it. So that's one thought. And again, some of our assumptions were quite optimistic, and the figures could actually be a lot more worse. I think in terms of lighting in replacement rates were pretty low, but it's likely that in the case study that we're going to be publishing, the figures will be a bit higher because we'll be a bit more nuanced in terms of the lighting replacement rates. I just wanted to make another point about data. You may have noticed that the figures are quite spread out between the low, medium, and high impact scenarios. So the way we created the scenarios is that we decided to use all data available, and then, you know, for the low impact scenario, always the lowest data, medium always the average, and high always the highest. So it can feel surprising how spread out it is. You know, for this Canadian project, again, you know, it's between 93 and 350 kilograms CO2 per meter square. So it's hard to know really where the impact lies in reality. But just to give you an example, you know, we have huge data variance at the moment within the data that exists. So I put an example for water source heat pump 10 kilowatt. You know, there is a factor of 10 between a product from this German database and from a French database. And same for copper, which is supposed to be quite simple. You know, you have quite different factors. Of course, it could be linked to the grid factor, which is not the same and everything. But the problem is that you don't always have the visibility and the transparency on the different assumptions of this database and where it comes from. So we think it's a problem, and you need to be really aware of where the data come from, and be consistent and be transparent on the assumptions you use. Ideally, you would like to use data from only one database, but in the case of MEP, it's really impossible. And it's really hard to find data in general. And on that note, we're actually finalizing a calculation methodology for MEP products when no EPDs are available, so environmental product declarations. Like, what do you do when you don't have any information? So we created like a conservative calculation methodology on what to do, and we're hoping that it will create more consistency, and at least for us, we're aiming to create kind of a generic consistent library that will help us early in the design stage to kind of do calculation. And this will be published as a SIPSI technical memorandum in the coming month. And we also are partnering with Building Transparency for the EC3 tool. So I don't know if you're aware of this database / tool that exists. It's from Seattle. So it's mostly a lot of American data, but they're trying to expand to European data. So hopefully it will be available soon and it's completely free to create MEP baselines per product type with, using the same methodology to kind of give some consistency and just some data to move forward and to do more research. Another point I would like to discuss is about refrigerant. So when we did our studies, and you've seen that in the first retrofit study, the part associated with refrigerant was massive. It was about 20% of your total embodied carbon impact of your building. So here in this US project, you can see that it's about between 12 and 30% of your total MEP embodied carbon impact, which is quite massive, and it shows that and the difference lies because so it's the same refrigerant in that case here, but we have applied different leakage rate and different recovery rate. And here we had a split system and a VRF system. But this shows us that if we have some, good maintenance, and we ensure high recovery rate at the end of life for the refrigerant, actually your refrigerant impact can go quite minimal. And here it's with a quite high global warming potential refrigerant. So, so we had done another study also on refrigerant that is available online. I can share the link, where we had showed that for a passive house type building, when there is high leakage and low end of life recovery, actually a associate pump or a VIF can be worse than a gas boiler or a CHP, because in passive house, buildings, the heating demand is very, very low. So that really spurred us to create like to put our thoughts and think about what refrigerant best practice looked like. And at first it was an internal conversations, and then it became a lot more interesting and a lot more detailed. So we said, okay, what about we don't publish it? So it's going to be published in the next month, maybe next week. We need detailing which measures to take, which low global potential refrigerants are available per system, how can you mitigate refrigerant leakage, and how can you enhance recovery, and also how can you reduce the charge per system. So it's detailing all this, and it will be updated as we find more learnings. And the last point I wanted to make, which is quite obvious, and it's Louisa already told it, but it's about the idea that less is more. It's like, obviously the less MEP systems you put in, the less embodied carbon you're going to have, and it's also the idea that you don't need to oversize your equipment, that you can design for 95 percentile, it's going to be fine. And if you reduce your load, you're actually going to reduce your embodied as well. And you can see that here, again, the across the different projects in the different regions, the total embodied carbon here for the medium impact scenario are quite different. But it happens that in the American project, they didn't put much in, and that was as simple as this. So I think calculations can be a bit overwhelming, but there are some key principles that are you kind of know it's a big win. Like if you put less, you kind of pretty sure you're going to have less embodied. And as Louisa said, it's likely that it's going to reduce your costs. So if I had to put kind of key takeaways on how to mitigate embodied carbon linked to MEP designs, I would appreciate that idea that less is more, and really try to design down equipments, but still asking for high efficiency. Kind of have the idea that you can design at MEP, and maybe there is like a transfer cost to more passive measures. Really, you can act on the easy wins, especially again concerning refrigerant, that are more and more used because the grid are decarbonizing. So you want, for heating systems like heat pumps, and the cooling demand, unfortunately, is really rising up due to a lot of different reasons. So refrigerant use is really on the rise, but you can, low glowing potential refrigerant do exist, and there are ways to really mitigate refrigerant leakage and enhance the recovery. And really, this really doesn't apply just for MEP, but asking for transparency, to have visibility on the supply chains, where things come from, and what's going to happen to these things on the long run, I think is really important. Asking for EPDs and long design life and adaptable for reuse, we think is really important. But I'm sure you all know this, because it's quite common sense when you think about it in this subject. Merci, as we say here, and I think we can have some questions.
Great, thank you, Louisa and Louise. With that, I'll invite Louisa back. Perfect. Okay, so a couple of questions. Louise, you mentioned a few reports. The one that will be incorporated into an appendix in the CIPSI TMXX. Where will that be published for people to reference?
So the CIPSI TM, we don't know the number. It's going to be published by CIPSI. So it will be available free for CIPSI members, and I think at a low cost for non-CIPSI members.
Okay, great. And then the report you mentioned, the refrigerant practice guide, is that going to be published on Integral's website, or?
Yes, yeah, it will be published on Integral website, and maybe we can do a follow-up, and it will be published on Issue. Great,
thank you. Okay, we had one question also for you, Louise. After extracting material quantities in building service systems from a BIM model, how do you account for A3, the manufacturing of the actual end products, say ductwork, chiller, AHU, heat pumps, etc., rather than the processed metal? And in your experience, is this a significant proportion compared to the other A modules?
Great question, thank you. So as we said, most data is pulled out from a lot of different database. So so we're just matching that data per element to the bill of quantities, and then just adding everything up. And from this database, we already have the figures, so we didn't have to go manually calculate it. But within the CIPSI methodology we are working on, we are actually detailing step by step how do you need to calculate it when it's not available. I would say it's hard to say because A1 to A3 is usually all together, and when you don't consider in use the use phase, yes, it's very much the highest part, at least for MEP. Usually when you have heavy things transport and construction, or at least transport is going to matter less. Whereas for light things, then transport matters more. So hopefully that responds to your question.
Great, thank you. Okay, I have a question for the two of you. So you both provided some really key takeaways, but if you had to give advice on a single most impactful thing designers or engineers could do today to reduce the embodied carbon of interior packages or MEP systems respectively, I'm curious what you would recommend. So maybe Louisa, we can start with you on that.
Yeah, I think it's a common thread that actually ran between my presentation and Louise's, which is replacement cycles. I think, you know, the finding on, you know, on the interiors that actually it could, you know, by the time you'd reach the end of a 60-year lifespan on a building or an asset, that you could, you know, over a number of replacement cycles, you could have added as much carbon into that building as you did at day one when it was completed. You know, that was a staggering finding for me. So I think looking at replacement cycles and how, you know, it's a cultural thing. It's, do we need to rebrand every time a company moves or a retail unit moves? Or, yeah, for me, that replacement cycles and I suppose the circular economy related to that is important.
Yes, I would agree. You know, at first I used this 25 lease period, but really when I was talking to mechanical, electrical engineers, they were saying, no, every 5 years, everything is stripped out, everything replaced. I was like, what? So I guess, yeah, we need to move away a bit.
I think it's different in different sectors. I mean, we work a lot in the civic and community and the education sectors, and obviously they're, you know, they're publicly funded and they get less capital funding less regularly. So we tend to find that they're often working with quite inefficient and quite you know, environments that are actually detrimental to productivity and health. So they leave things perhaps too long, and maybe they're more inefficient because of it. But certainly, you know, the way that some of the sectors work on replacement cycles is an issue. Yeah.
Absolutely. So I'm guessing those conversations really start with the client when they approach you with a project, a tenant improvement project, or do those conversations start earlier?
I can take that. I think they should do. There was an initiative a few years ago about green leases, and to my knowledge, they didn't kick off in a huge way, but I think they were influential in at least starting the conversation between landlord and tenant. And that's probably where it comes in the most, where you're not an owner-occupier, you're not necessarily as in control of the decisions being made, for example, as where you have a landlord and tenant relationship. So it works both ways, the landlord being clear to the tenant about the expectations. And, you know, maybe we see this more, you know, when we start measuring whole life carbon and life cycle, that actually that gets handed to the landlord as a design documentation at the end of a project, and it's their responsibility to monitor, you know, the fit out in relation to the design expectations so that the whole life carbon emissions remain below a benchmark, or at the very, you know, use the word offsetting, that will you know, may engender a few questions. But yeah, I think it needs to be on the agenda now that we've got some of the data to show how important it is. It needs to be part of those early stage meetings. Yeah,
Absolutely. Louise, anything to add there, or no? Great. Okay, I have a question for you, Louise. When we're talking about looking at the amount of existing building stock we have globally already, and this ties into the tenant improvement conversation as well, but I'm curious for MEP systems in particular, when we talk about efficiency upgrades, that also often involves replacing the HVAC system for more efficient systems. Have you found a difference in embodied carbon impacts from older systems versus newer, more efficient systems, or not so much?
That's something we want to look at, because in the long term, if we put really, you know, from very low efficient equipment to very high with minimal changes in terms of equipment, and that it doesn't imply more thing you put in your building. I still think you can do a lot of savings, but we actually haven't really calculated, put figures on those numbers. It's something we would like to do, because we know refurbishment is important, and to really see, okay, you might have an embodied carbon impact, yes, but you do also some savings.
Right, exactly. Comparing that to the lifespan of that product and its operations. Absolutely. I think that's it that we have for questions, and we're right at the end of our session time. So I just wanted to thank both of you for your presentations and your expertise and insight. And thank you to all of our attendees for joining the Carbon Positive Reset. This is our last session of the day. We have one more round of 30-minute tool demos that I encourage you all to join. But on behalf of Architecture 2030, I just want to say thank you for joining, for all your insightful questions throughout the day, and for your curiosity and eagerness to create a positive change. And with that, I will go ahead and conclude the session. And thank you again to Louise and Louisa.
Thank you.
Thank you. Thank you.